Mommy Classe. Welcome to algebra, and we're going to talk about radical expressions today. So recall that 5 squared really is 5 times 5, which is 25. Hopefully you know this. I would say you do. All right, so the opposite of squaring, also called the square, okay, so the opposite of squaring, a number is taking its square root. Okay? So, for example, if I had, we'll say 6 squared is 36. Well, the opposite of that is the square root of 36 is 6. Okay? Because 6 squared is 36. Okay, but there are more than just square roots. So let's just talk about a few other ones. We have things called cube roots, which look like this. Fourth roots, which look like this. Fifth roots, which look like this, okay? Well, the fourth root of, let's see, that would be the fourth root of 625 is 5, okay? Because 5 to the fourth is 625. 5 to the fifth, on the other hand, is a little more complicated. 5 to the fifth got 5 to the fifth is 625 times 5. So 12. So the fifth root of 3,125 is 5. Okay. Well, what about the cube root? Well, 3 cubed is 27, so the cube root of 27 is 3. The fourth root of 81 is 3, and the fifth root of 243 is 3. For 2, these are a little easier to remember in my opinion. The cube root of 8 is 2, the cube root of 16 is 2, and the fourth root of 16 is 2, and the fifth root of 32 is 2. Okay? So, there we go. All right, so in general, the nth root of a is a number whose nth power equals a. That is, the number a is the radicand. N is the index or order, okay? And the expression nth root of a is a radical. Okay, so let's just label this. This is the index. This right here is called the radical sign. And this stuff inside is called the radicand. And the whole thing is called a radical. Okay? Now, as a convention, when taking the square root of a number, we generally don't write 2 square root, okay? Or 2 radical, okay? It's only the square root, this thing, the radical sign, okay? Because generally speaking, this is the one you're taking. Now, if you want to specify a more specific, have a more specific one, cube root or something, then you need to write which one it is. All right, so for examples, here we're going to simplify. What I like to do is, if I'm not sure, now I know the cube root of 27 is 3, but for 216, I may not know what the cube root of 216 is. I probably should, but if I don't, I'm going to go ahead and factor it. Now, I know 6 is a factor of 216, and I also know that 216 divided by 6, if I go ahead and divide it, is 36. Well, 36 is a perfect square. Notice that there are 3 6's in 216. That means 6 cubed equals 216. So 6 is my cube root. All right, 256, the fourth root of 256. Well, 256 is, let's see, that's, I know I can take out at least a 4. So that's going to be, let's see, 25 divided by 4 is 5, 6, sorry. And that would be 64, and that is 8 times 8, which is 4 times 2 and 4 times 2. Now, at this point, it doesn't look like I have a fourth root, but look closely. 1, 2, 3, and then this one and this one make my last 4. So 4 to the fourth power is 256. So 4 is my fourth root. Okay? So let's look at this one. This is, the fifth root of this is 3. I know that from knowing it, but let's look at what we've got here. We've got 24 and 3. I know that's divisible by 3. 24 divided by 3 is 8, so that's 81. 9 times 9, 3 times 3, 3 times 3, 1, 2, 3, 4, 5 threes, so 3 is the fifth root of 243. The fourth root of 16 is 2. So this equals 2. The fourth root of 81 is 3, so it's 2/3. If I wanted to check that, I would say, okay, 16 is 4 times 4, which is 2 times 2 and 2 times 2, so 4 2's. And the fourth root of 16 is 2, and the fourth root of 81 is 3. All right, now let's look at this. The third root, the cube root of 0.064. Well, it's hard to do decimals, so I'm going to write it as a fraction. That's 64 1/1000ths. Okay, well, the cube root of 64 is 4, and the cube root of 1,000 is 10. So this simplifies to 2/5, right? Or 0.2. 0.4, I'm sorry, 0.4. Okay? All right, so squares that you should know. Here we go. 2 squared is 4. 2 cubed is, okay, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. You should know all of these squares through 15 at least, and you should definitely know 20, which is 400. Okay? Another set that you should know are the cubes through 10. So the cube of 2 is 8. So 8, 27, 64, 125, 216, 289. Okay, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1,000. Okay, 10 to the fourth is 10,000, 10 to the fifth is 100,000. Okay, so those are some you might want to just keep track of. But the other ones, all right, so 2 to the fourth power, 2 to the fourth power is 16, 2 to the fifth power is 32. 3 to the fourth power is 81, 3 to the fifth power is 243. 4 to the fourth power is 256. 4 to the fifth power is 1024. Okay, 5 to the fourth power is 625. 5 to the fifth power is 3,125. 6 to the fourth power is not really that necessary. Okay, guys? All right, so definitely know all of these squares, these cubes, be able to recognize definitely all the way through 7, 8, 9, and 10, definitely 10, but 9 and 8 and 9, you can multiply them. Know the 2 all the way to the fifth power, 3 all the way to the fifth power, 4 and 5, you need to know 4 to the fourth, 5 to the 4th is pretty important. These two can kind of, you can multiply those. All right? Principal roots. Okay, if the index is even, then positive numbers have 2 nth roots. For example, okay, if I have 4 and -4, I can square them both to get 16, okay? So 4 squared is 16, and -4 quantity squared is 16, okay? So the square root of 16 are 4 and -4, and 4th roots of 16 are 2 and -2. So in these cases, if I have something that looks like this, this indicates the positive root or the principal root, okay? So if this is even, then I understand this to be the positive root, okay? So in this case, this is the positive root, or also known as the principal root. I'm sorry, principal. And this indicates the negative root. Okay? So, in general, if n is even and a is positive or 0, okay? So, we're assuming this is positive. The nth root of a represents the principal nth root. Of a, and this negative represents the negative nth root of a. Okay, and if n is odd, or even, if n is even and a is negative, then the nth root of a is not a real number. And we're going to leave it at that. Okay, so if I'm trying to take the nth root of a negative number, then it's just not real. Okay? If n is odd, then there is exactly one real nth root of a written the nth root of a. Okay, so if n is odd, the negative positive thing doesn't bother me at all. I can have a negative nth root, I can have a positive nth root, it's not a big deal. But if n is even, square roots, 4th roots, 6th roots, 8th roots, then I have an issue. I have a positive root and a negative root. So, find each root. Well, this is telling me find the positive square root of 36. Well, that's 6. This is asking for the negative square root of 36, which is -6. This is asking for the positive 4th root of 16, which is 2. This is asking for the negative 4th root of 16, which is 2. This is asking for the 4th root of -16. This is not a real number. Okay, I can't have the 4th root of -16. Now, the 5th root of 243, I know, is 3. And the 5th root of -243, since this is an odd index, this would be -3. It's okay to have a negative radicand when it's an odd power, or an odd root. Okay, so what you're going to do for homework is you're going to do numbers 3 through 39, multiples of 3, all right, from page 471. Now, what you need to do for the rest of class is we have a test next class, so you need to go to page 457 in your book, okay, and do all of the problems 1 through 24. Okay, numbers 1 through 24, all. You can't do numbers 25 and 26, or 27 or 28. So that should be it. Okay? What you might want to go ahead and do is then go to numbers 43 through 52 and do those. Okay? The mixed review exercises. Oh, there's more. Maybe 50, 24. Do 54. Okay? All. And I've given the sub a key to all of these problems, so when you're working on these, you are allowed to have the key so that you can check your answers. Okay? All right, see you guys later.